Random walk. A king can move one square in any direction, up, down, or side to side. Let xn be the sequence of squares that results if we pick one of the king's legal moves at random. Find the stationary distribution, and what is the expected number of moves to return to the top left corner when we start there. Now note, for those of you that don't play chess, it's a game played on an 8x8 board. There's multiple different pieces that can do a lot of different things. Some pieces can scale the entire board diagonally. Some can jump pieces going up 2 and over 1. But in our case, the king can move one square at a time in any direction. So note that they ask us to find the stationary distribution. So what that's going to be in a case like this is going to be the number of moves from any certain position divided by the total number of moves possible in the entire board. So what I've done here is I've populated the number of moves per position, and we're just going to check and see if these are right. So if we start here, they want us to start at the top left corner, so we'll start here. Now, there's only 3 possible moves we can do if we can only move one square at a time, right? We can either go here, here, or here. Now, likewise, if we're at an edge position, there's only 5 possible moves. 1, 2, 3, 4, 5. And again, we'll just pick something random in the middle here, just to give you a feel for each different possibility. Now there's only 8 different possible moves we can make if we start at that circled position there. So like I said, the stationary distribution is given by whatever position you're starting at, the amount of moves you can do there divided by the total amount of moves on the board. So we've got 4 different corner positions where we can move three moves there. Now, there's 24 different edge positions where we can move five different places. And there's 36 different places where the total number of moves is 8. So I'll just put this in brackets to note that we are multiplying these numbers. And this equals 420 total moves. So if we wanted to pick, the stationary distribution for the top left, and I guess I'll just put TL for top left. It's just going to be the number of moves in the top left corner, which is 3, divided by the total number of moves on the board. And this makes sense, right? If we added up all of these stationary distributions, it would come out to 420 over 420, which is 1, which is what we want. So it's kind of tedious, but you can see we just multiplied those numbers above. It does in fact give us 420, so 420 over 420 is 1. Now moving on, what is the expected number of moves to return to the top left corner when we start there? So essentially what they're asking us for is, I'm going to keep the acronym TL for top left. This is what we want to find, right? The expected number of moves to get back to where we started. So we have a theorem here. If P is irreducible, and remember that irreducibility simply means that we can get from one place to another and back again. So if we start at the top left, we can move any position on the board in a certain number of steps and get back to the top left in a certain amount of moves. And we can do this for any position on the board, right? The king can go to any position and get back to any position. So therefore, it is irreducible. And a stationary distribution exists. Well, we just found the stationary distribution for the top left corner. We could do it for something like, I don't know, the bottom left or the position to the right of that. It doesn't really matter, but we can find any stationary distribution, right? Then we have the stationary distribution just equals 1 over the expected amount of moves to get back to, in the theorem here it uses y, but we're using TL. So if we take the reciprocal of that, this just equals 1 over pi of TL, right? Can you see this? So this would just be EY TY equals 1 over pi y, straight from our theorem here. Well, we just found what the stationary distribution is for the top left corner. So the expected number of steps is just going to be essentially 1 over that. So it's 1 over 3 divided by 420, which equals 420 divided by 3, which equals 140 expected number of moves to get back to the top left corner if you started there. And that's it.